Hi. So I'm going to continue now with applications of differentiation, another problem here. It says, which points on the graph of y equals 4 minus x squared are closest to the point 0, 2? Okay, so here's the situation. I'm going to show you something. There. All right. So here you got a point here that's 0, 2, okay? And you have this graph here, which is y equals 4 minus x squared. So because the a coefficient in the parabola function here is negative, you got a parabola with a concavity down. And you got this point right here. You can see visually that it's the closest point to the point 0, 2, but how do you find it? Okay, well, that's what we're here for, right? So you have this function here, y equals 4 minus x squared, and then you got another function of the distance. Okay, what is the distance between any point, an arbitrary point on the graph, and the point 0, 2? Well, according to the Pythagorean theorem, it's going to be the square root, okay? Because this is what we're going to do, guys. See here? No, let me get another color. There. Hold on. So you have this here, which is the horizontal distance, the distance in the x-axis between this point and this point, and then you got a vertical distance, right? So if you want to find this distance here, what you got to do, well, this is a right triangle, so it's just going to be, well, let me say here, the arbitrary point, okay, on the graph minus 0, because 0 is the coordinate of this point right here, squared, plus y, an arbitrary point on the graph, minus 2 squared. If you don't understand what I'm doing, well, some people do understand, but others don't. So you have this, right? Here. I like to make it explicit, guys, because some people find it hard. So what do we have here? We have the point 0, 2 here, okay? This is the coordinate. And you got a point here, which is x and y on the graph, okay? The graph is going like this, right? It's going through this point here and blah, 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 like this. Oh, well, this is a perfect parabola. Okay, so what is the distance between these two? Well, what is the x coordinate here? It's going to be this distance squared plus this distance squared, and you check the square root of the result, okay, to find this distance, because this is the distance that you want to find, okay? So you got the square of one side plus the square of the other side, then you check the square root of the result, and you're going to find this distance. This distance is this one here, okay? So that's where this formula here comes from. All right. Now we got to relate these two formulas. Well, that's easy. Y equals 4 minus x squared. So the distance equals the square root, I'm going to make this very long, of x squared plus, what is y? 4 minus x squared. So it's going to be 4 minus x squared minus 2 squared. That's the distance of the formula. Okay, so 4 minus 2 is just going to be 2. I'm going to already fix this up in here. Okay, so we have that. And I don't know if I already try to expand this. It's going to be 4 minus 4x squared. I think I'm going to try to expand this plus x to the 4th. Okay, so this is this expanded. That's this binomial expansion. So 4 squared minus 4 minus 4x squared plus x to the 4th. Okay, and then you have an x squared here. So actually it's going to be minus 3x squared minus 3x squared. So you got the square root of all that, okay? Which is the same as saying that this is being elevated to the power of half. This is d. Okay, so let's differentiate this stuff with respect to x, okay? We're going to differentiate d with, well, yeah, differentiate d. This is the d of the differentiation, and this d is this d, okay? With respect to x. And we're going to equate that to 0. So this has to be equal to what? Well, it's going to be half of this to the minus 1/2, okay? So I'm going to put all this in here, and I'm going to put the square root of 4 minus 3x squared plus x to the 4th, all right? And this is going to be multiplied by the derivative of this inside equation, right? Which is going to be, so it's going to be 1, well, 1 times whatever is whatever. So I'm going to get this 1 out of here. And then you have minus 6x, okay, plus 4x cubed. So this is the differentiation, and you got to equate this stuff to 0. Well, you cross multiply, thank God, so you don't have to deal with this huge x squared here, okay? So we have, forget about this, right? And then you have this thing here, okay? I'm gonna do like 2x. I'm gonna factor 2x out of this. So this is gonna be 2x squared, right? 4x cubed divided by 2x is 2x squared. Great. Minus 3 equal to 0. So this 2 here, you can just get rid of it. And then you have x equal to 0. Okay, is the distance equal to, oh, okay, yeah. You got x equal to 0. Okay. And and you got another one, which is x 2x squared minus 3 equals 0. That means that x equals plus or minus the square root of 3 divided by 2. Okay? This is a 3. Okay, so yeah, plus or minus square root of 3 divided by 2. Now, what is that? Well, you see, so for x being 0, that means that's going to be this point here, but that's not what we want, okay? Because you see, this is the derivative. Now, when is the derivative going to be 0? When x, oh, hold on. When x equals 0 and when x equals plus or minus square root of 3 divided by 2. So these are relative minimums or maximums, all right? But if you use the first derivative test, you're going to verify that x equals 0 yields a relative maximum, whereas both x equals square root of 3 divided by 2 and minus square root of 3 divided by 2 yield the minimum distance. Right? So, let's see here. If you put, let me think here. If you put an x equals 0, okay, in this graph here, when is x equals 0? At this point, okay, so it's going to be x equals 0, and what's going to be the y? The y is going to be 4. Okay, so the distance, you can visually see this here, that the distance between this point and this point is 4 units. Why? Because the x is not changing. Okay, actually it's going to be 2 units, right? From here to here you got 2 units. Because this is 0, 4, and this is 0, 2, so it's going to be 2 units. So the distance using x, oh man, I'm going to start erasing some of this stuff. I didn't want to do that, but I have to. So for x equals 0, the distance is going to be 2. All right. Now what about x equals square root of 3 divided by 2? Well, let's see then. Y equals 4 minus x squared. So it's going to be minus 3 divided by 2. All right. You can just put a 2 here and replace this with an 8. So it's going to be 5 divided by 2. Okay. Now, so you have another point. You have another point that is x is square root of 3 divided by 2. And the y is going to be 5 divided by 2. All right, now let's see what the distance is going to be, because when x equals 0, we saw over here when x equals 0, okay, the y is going to be 4 and the distance will be 2. What about when x equals, because there's something else that I want to show you guys. You see, because the parabola graphic over here is symmetric about the y-axis, this distance is going to be exactly the same as this distance. Okay, so and there's something else here. You can put plus or minus square root of 3 divided by 2 in x, meaning this point or this point, the value in y is going to be the same, which is 5 divided by 2. Now let's try that. Okay, what is the distance again? The formula of the distance, square root of x minus 0. Oh, x is just square root of 3 divided by 2. So we have square root of 3. Oh yeah, it's the square of that, right? Because you see, guys, what you have is x minus 0 squared. Remember that? And then you have plus y minus 2 squared. I mean, if you go back in the video, you're going to see that this. So d equals the square root of what is x minus 0 is just x squared. So it's going to be 3 divided by 2. Let's check the positive. 3 divided by 2 plus. This is 2.5. Minus 2 is half. Squared is 1/4. Okay. So we can put d equals the square root of, I'm going to put a 4 here. So this is going to be a 6. Okay. 4 divided by 2, 2 times 3, 6, plus 1, which equals the square root of 7 divided by 2. Now, if you go on the calculator, let's see something here. Square root of 7, okay, and then you divide this thing by 2, you're going to see that's 1.32 approximately. So the distance here is going to be approximately 1.32, blah, 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 blah. Well, this is less than that, okay? D equals 2. So you can see that the smallest, the distance, the shortest distance between this D and an arbitrary point in the graph is this one here, when x is plus or minus square root of 3 divided by 2. Okay, actually I made a little mistake here, guys. It's supposed to be this whole thing here, okay? it's square root of 3 divided by 2. It's not square root of 3 divided by an integer 2. So x equals plus or minus, square root of 3 divided by 2. Everything's inside the square root. Okay, and that's it. Okay. Now we got something else here. Look, it's another problem, okay? A rectangular page is to contain 24 squared inches of print. The margins at the top and bottom of the page are 1.5 inches or 1.5 inch, and the margins at the left and right are supposed to be 1 inch. What should the dimensions of the page be so that the least amount of paper is used? So let's see the picture here. This is the picture. Okay. So what is the thing asking again? What should be the dimensions of the paper? That will be the area of the paper. Okay. So we can see that the area of the paper is going to be this whole thing in here times this whole thing in here. This is a rectangle. Okay. So you see, we're going to say that x is how much is the distance or the dimension of the printed area. Y is the dimension, I'm sorry, x is the horizontal dimension of the printed area, and y is the vertical dimension of the printed area. Okay? So, what is going to be the area of the paper? The area of the paper is going to be x, which is the horizontal print, okay, plus 1 inch on one side and another inch on the other side. So it's going to be plus 2. This is the area of the paper. Okay, print paper. I'm going to say like, just leave it. So this is the area of the paper, x plus 2. Now you got 1.5 inch on top and 1.5 inch at the bottom. Okay, so this is going to be y plus 3. This is what you want to find out. What should be the area of this thing? Okay, now look, a rectangular page is to contain 24 square inches of print. So the print in horizontal is x and in vertical is y. So xy is supposed to be 24. Okay, so now all you got to do is because you see guys, a, which is what we're trying to minimize, okay? Look, what should be the dimensions of the paper so that the least amount of paper is used? What should be the dimensions of the page so the least amount of paper is used? So you see, you have an area which depends on 2 independent variables, x and y. And you want to differentiate this thing, okay? You want to differentiate the area with respect to just one independent variable. It could be x or y. Well, let's just choose x, okay? And you want to equate this to 0. Why? Because, for example, x, you have just 1 inch in horizontal print, and y, you have 24 inches. So you could have a print that has this format right here. Kind of like that. Now, is this going to use the smallest amount of paper, the least amount of paper? Maybe not. Maybe you got a print that is 24 inches across, 24 inches in the horizontal, and just 1 inch in height. So you're going to have a paper like this, a print like this, okay? Now, is that going to use the smallest amount of paper? Maybe we should do this, get this one here, put it a little bit wider here, and go like that. So what's going to be, this is the problem. What is the least amount of paper that's going to be used according to the print format? Which print format should we use to use the least amount of paper? So what I'm going to do, and what's going to happen? As you choose the wrong X and Y, you're going to have huge amounts of paper, okay? Huge amounts of paper, maybe like that. I don't know if this is what the graph will do. It's just a hypothesis here. I'm just supposing that this is what the graph will do. But at some point for X and Y, you're going to choose some value that's going to use the least amount of paper right here. And then the amount of paper just keeps growing and growing and doing crazy stuff in here. So what you want is to find out this optimum thing. Okay, here you're going to have a graph like this. Because it's obvious to me, but it's not obvious maybe to people that are trying to understand this for the first time. So you have X or Y in here, and you're going to have A here. Okay, so what you want, you cannot have a negative A. Okay, this is not going to come here. It'll go kind of like this. You cannot have a negative area. So this is going to be the least amount of paper the least amount of paper, the smallest area in the paper that's going to be used according to a certain value of X. If you choose any other value of X and Y, you're going to have to use more paper. It's just that I like to help you guys visualize what's happening. And to find out that minimum, remember, to find out that minimum, you want the tangent here to be 0. That's why we're going to differentiate A with respect to X and equate it to 0. Now, this function depends on two independent variables, X and Y. So I want to make this Y go away. So Y equals 24 divided by X. So this equals X plus 2 times 24 divided by X plus 3. Okay guys, what happened? I had to stop the video, so I edited this video like this is the second part of the video. Okay, what made a mistake with me is that the book chose to, I just got crazy a little bit because the book chose X for the vertical distance and Y for the horizontal distance, but I don't agree with this. Okay, I like X for the horizontal and Y for the vertical. So I'm gonna do this. I'm gonna cut this, and this is X, and here this is Y. Okay, now let's do it again. So the area of the page is X plus 2, okay, right, plus Y plus 3. So Y equals 24 divided by X. And I just put 24 divided by X here, great, okay. So let's multiply this out. So it's going to be X times 24 divided by X. You got 24 plus 3X plus 48 divided by X plus 6. Okay, this is the area, and I'm just going to differentiate this area with respect to X. So this is going to be 0, this is going to be 0, and dA dx equals 3, okay, minus 48 divided by X squared, and this has to be equal to 0. So I'm going to take the minimum common denominator here, okay, multiplying, cross multiplying, this thing here is going to disappear, and then you have 3x squared equals 48, x squared equals 16, x equals plus or minus 4. But you cannot have a negative 4, okay? How can you say that this x in here equals minus 4 inches? Crazy. So you discard the negative 4 here, and you know that x equals 4. Okay, now if x and y, xy equals 24, you know that y equals 6. Okay, so you're going to have a page where you have 4 inches of print in here, 6 inches, 6 inches of print in here, and then you have 1 inch of margin here and another inch of margin here. Okay, and over here at the top you have 1.5 inch in here, and here at the bottom you have 1.5 inch. So there you go. Okay, I'm gonna stop this video now.